start, smash the like and subscribe buttons for more updates. The observable universe is defined by the maximum distance light has been able to travel since the Big Bang, approximately 13.8 billion years. Due to the expansion of space, the horizon stretches to about 46.5 billion light-years in any direction, forming a bubble-like sphere with Earth at the center. Anything beyond that limit, according to standard cosmology, should remain invisible to us, not because it doesn't exist, but because its light hasn't had enough time to reach us. For a telescope to claim to see beyond that cosmic horizon was previously considered, in most respects, to be theoretically impossible. Yet, the James Webb Space Telescope, launched with the express mission of peering deeper into space and further back in time than any of its predecessors, has accomplished what seemed implausible. With its unmatched infrared sensitivity and revolutionary optical systems, JWST has uncovered signatures, distinct, distant, and statistically consistent, of 750 galaxies whose apparent locations lie just past what conventional physics tells us we should be able to see. These are not marginal, debatable detections either. The signals are robust, confirmed over multiple observations, and have been carefully scrutinized for instrumental errors or interference. The implication of this discovery is profound. Either our understanding of the speed and travel of light in an expanding universe is incomplete, or some form of observational illusion or misinterpretation is occurring. But if the preliminary analysis holds, these galaxies lie beyond the edge of what we thought was visible space. What makes this even more riveting is the nature of the galaxies themselves. Initial spectroscopic readings suggest that they are not uniform or featureless. These are fully structured systems, some with early indicators of complex morphology, including spiral arms and dense star clusters. Their light, reddened by extreme cosmological distances, shows signs of significant stellar activity. That implies they are not nascent collections of gas clouds, but mature, or at least maturing, galaxies with lifespans that could stretch billions of years into the past. The possibility that these galaxies existed and evolved in regions that were once thought unreachable opens a floodgate of questions. Were these galaxies formed in a separate pocket of the universe with different initial conditions? Are we seeing their images due to some exotic curvature of space-time, perhaps amplified by gravitational lensing on an unimaginable scale? Or, more radically, is the observable universe merely a portion of a much larger, more complex cosmic structure, one that JWST is only now beginning to reveal? For decades, cosmologists have worked with the assumption that, while the universe is potentially infinite, the observable portion is all we could access. What JWST is now showing suggests that, under certain circumstances, the boundary may be more permeable than we thought. One potential avenue of explanation lies in the properties of inflation, an incredibly rapid expansion that the universe underwent in its earliest fractions of a second. Some cosmological models of inflation predict the possibility of bubbles or islands in the cosmic fabric, pockets of reality that branched out in different directions, possibly even governed by slightly different physical constants. Could it be that JWST has stumbled upon light from such a region, piercing through the veil of our own cosmic horizon? There's also speculation that advanced gravitational lensing, where massive foreground objects like galaxy clusters bend and magnify light from more distant sources, could be playing a role in these detections. However, the sheer number of new galaxies, 750, makes this explanation strain credibility. Gravitational lensing can indeed amplify single galaxies or even groups of them. But the statistical spread and uniform distribution of these new detections suggests something more systemic. It's as though a curtain we didn't know existed has been pulled back just slightly. And beyond it lies a staggering multitude of ancient galactic cities, burning their quiet fires across the cold dark. These galaxies also bear witness to times incredibly close to the dawn of the universe. If the JWST is capturing their light, then that light has traversed space-time for billions of years, potentially longer than any light previously observed. That puts these galaxies in a position to tell humanity untold stories of cosmic infancy. They could carry secrets about the very first stars, the formation of black holes, or the earliest heavy elements forged in nuclear furnaces not long after the Big Bang. The implications for theories about dark matter and dark energy are also immense. These two phenomena, which together are thought to comprise around 95% of the universe's mass-energy content, are still largely inferred rather than directly observed. If JWST is now peering into areas that were thought unreachable, it may find new distributions of matter and energy that defy previous mappings. Perhaps dark matter behaves differently in these extended regions. Or maybe new kinds of matter or energy states exist there entirely. Every new galaxy adds data points to an already complex puzzle, and these new findings expand the puzzle into a previously invisible dimension. Moreover, these observations could fundamentally reshape our ideas about time and causality in the cosmos. If we can see galaxies beyond the point where light should be able to reach us, perhaps the temporal structure of the universe isn't as fixed as previously believed. Some theorists have already begun to wonder if time itself might have different textures or rhythms at different cosmic scales. This was once the domain of speculative philosophy, but JWST's data might elevate such discussions to scientific debate. The technical feat itself cannot be understated. To achieve this level of observational penetration, the James Webb Space Telescope relied on its deep field imaging protocols, which involved staring at one section of space for days or even weeks. The precision needed to filter out false positives from cosmic dust, background radiation, or nearby interfering stars is immense. The engineering sophistication behind this instrument, cooled to near absolute zero, situated at the second Lagrange point, and operating flawlessly in deep space, is a triumph of human ingenuity. All this opens the door to a thrilling frontier in astrophysics. The universe, which once seemed so vast yet definable, now stretches into a dimension that may be mathematically finite but observationally boundless. There is a certain poetic gravity to that idea, that in seeking to know the edge of all things, we've instead discovered that there may be no true edge at all. These newly spotted galaxies hint at a universe that is not only larger, but more intricate, nuanced, and interconnected than our most ambitious theories dared imagine. The psychological impact of such a discovery cannot be ignored either. For centuries, every leap in astronomy has reduced humanity's sense of centrality in the cosmos, from Copernicus moving Earth out of the center, to Edwin Hubble revealing other galaxies beyond the Milky Way. And now JWST pulling back the cosmic veil once again. The arc of discovery bends toward humility. And yet within that humility lies a kind of majesty, a recognition that the universe is not just bigger, but infinitely richer than we can yet grasp. While the JWST's mission is still unfolding, the discovery of 750 galaxies beyond the supposed bounds of the observable universe stands as a watershed moment. It forces a re-evaluation of the fundamental principles of physics and astronomy. It encourages a deeper look at how we define visibility, distance, and even existence in cosmic terms. It places humanity once again on the edge of a vast unknown, armed only with curiosity and the instruments we've built to extend our reach. As new models begin to account for these observations, theoretical physicists and cosmologists will undoubtedly be drawn into fresh debates. Does this mean the universe is older than we think, or just more layered? Could there be inter-universal leakage, regions where space-time itself folds or tunnels in ways that allow light from one realm to trickle into another? Or is our measurement of distance and time subtly skewed by factors we've yet to account for, like undiscovered quantum gravitational effects? There's also the tantalizing possibility that these galaxies belong to a universe that coexists with ours, one that is part of a multiversal structure. This idea, long relegated to the fringes of scientific theory, might now merit deeper exploration. If JWST has given us a window into such a space, it could open the floodgates for a new era of scientific philosophy, blending cosmology with metaphysics in unprecedented ways. Furthermore, this development enriches the philosophical implications of existence itself. The more the cosmos expands in our understanding, the more it challenges assumptions about what it means to be alive, aware, and situated in space and time. The detection of these distant galaxies stretches the boundary not just of the visible universe, but of imagination, of what questions we are even capable of asking. There is no conclusion here, only a door flung open to more questions, more observations, more wonder. The galaxies are there, undeniably, in the cold, dark silence that JWST has illuminated with a whisper of light. They were waiting for us all along. And now that we've seen them, the cosmos will never look the same again. The revelation of 750 galaxies beyond the previously defined observable boundary is not merely a cosmic anomaly. It is a seismic transformation in how humanity situates itself within the cosmos. Having confirmed these galaxies with increasingly sophisticated instrumentation and data verification methods, scientists now stand on the edge of a cosmological recalibration. The sheer volume of new data is already triggering a race to reinterpret long-standing theories in particle physics, relativity, and quantum mechanics. Each of these galaxies may act as a discrete piece in a much larger puzzle, one that is revealing itself faster than theoretical models can keep up. One of the most compelling ramifications of this discovery is its impact on the understanding of cosmic inflation. This rapid expansion, believed to have occurred just fractions of a second after the Big Bang, is responsible for the large-scale structure of the universe as we know it. However, The uniformity and placement of these newly detected galaxies challenge the inflationary paradigm. If inflation was more chaotic, less homogeneous, varied across different sectors of the early universe, it could account for why these galaxies appear where they shouldn't. In this light, JWST's discoveries may be peeling back layers of ancient inflationary dynamics that the cosmic microwave background radiation, our previous oldest observable relic, never revealed. This leads scientists to consider whether inflation could have occurred unevenly, creating hidden pockets of matter that only now, billions of years later, are sending their light far enough and clear enough to be detected. The discovery also compels researchers to revisit the geometry of the universe itself. According to general relativity, mass curves spacetime, and on cosmic scales, this curvature can determine the overall shape of the universe, whether it is flat, open, or closed. For years, evidence has pointed toward a spatially flat universe. However, detecting galaxies beyond the theoretical visual edge implies that spacetime might be curved in ways we hadn't previously detected, or at least misunderstood. It's possible that we are observing light that has taken an unexpectedly long or curved path through a warped universe, making these galaxies appear farther than they should by conventional Euclidean distances. In such a scenario, non-Euclidean geometries could come into play significantly. Light might be bending through extra-dimensional curves or interacting with exotic gravitational wells, enabling the visibility of regions otherwise considered hidden. If higher dimensions do exist, long theorized in string theory and other advanced physics models, then these dimensions may be playing a more direct and observable role than previously assumed. JWST